In this video, we're going to continue our review of Unit 3. This is the Unit 3 review part 2. We're going to be working with some algebra today. So we're going to solve for x, y, and z so that line A is parallel to line B. And line P is parallel to line Q. And then name the theorem or postulate that's used. Okay, so first thing we can do, if I want to show that lines P and Q are parallel, I can say that this angle, which is the alternate interior angle with 52, those are congruent. So 2x is equal to 52. Divide both sides by 2 and we get 26. So x is 26, and this is alternate interior angle converse is going to prove that P is parallel to Q. Okay, so we figured out this first one, and we know that this angle here is 52. So I'll just mark that. Okay, so 52, and if I were to prove that A is parallel to B using P as my transversal, then I could say that, well, angle Z and angle 52 are supplementary because those are same side interior angles. Whoops, get rid of that. Don't know what's going on here. Sorry about that. Okay, so same side interior angles are supplementary. So 52 plus angle Z is equal to 180. And so subtract 52, so let's see, what's 180 minus 52? Do a little algebra, or a little arithmetic. That's 8, and how about 128? So angle Z is 128. And those are same side interior angle converse is going to prove that A is parallel to B. All right, last one. So we know that this guy is 128. Okay, so Z and this angle here, I guess fine. Those are alternate interior angles. If I wanted to prove that P is parallel to Q, see how they're in those angle groupings? And A would be the transversal. These are alternate interior angles, and alternate interior angles are congruent. So I have 128 is equal to 6y plus 8. And if I just subtract 8, I get 120 is equal to 6y, and divide both sides by 6, I get y is equal to 20. And those are, alternate interior angles converse proves P is parallel to Q. And there are more than one way to justify, but these are the ways that I did on this review. No matter what, we should still get the same answers for X, Y, and Z. Okay, in 39, what do we notice? Well, what I notice is I've got parallel lines. Here's a transversal. I can say that this 5x minus 16 is congruent to 4x plus 2. Okay, so by the alternate interior angles theorem, 5x minus 16 is 4x plus 2. If I subtract 4x on both sides, I'm going to have x, and if I add 16 to both sides, that'll give me 18. So I know that my x value is 18, and let's see, what's 4 times 18? 18 times 4, let's see, 8 and 4 is 32, 72 plus 2. Okay, so what I've done is I figured out what this angle measure was, and it is 74. If I substitute in the 18 for the x, add 2, I get 74. And the reason I did that is because now I'm looking at this line being parallel to this line with this as my transversal. So that means these are on the same side of the transversal, and same side are supplementary. So 5y plus 11 plus 74 is equal to 180. Supplementary adds 180. So let's go ahead and combine the 11 and 74. That make 85. Subtract the 85 from both sides. And let's see, I believe that would be 95. And if I were to divide both by 5, y is going to give me 19. And now I've solved for my x and y. Okay, number 40. If a transversal is perpendicular Okay, so I'm going to draw a picture on this one. To one of two parallel lines. Okay, let's draw two parallel lines, and I'll do my little chevrons on them so I'm not guessing whether these are parallel. I know that these are parallel lines. And a transversal is perpendicular. Here's my transversal. It's perpendicular to one of those parallel lines, which statement is not correct? Well, what I do know is that if it's perpendicular to one of the lines, it's going to be perpendicular to the other line as well. Okay, so all the angles formed are congruent, and that's true because all of them are 90 degrees. If you've got one 90 degree, then these are all 90 degrees because they're vertical or supplementary, so they're all 90 degrees. And I can just draw little right angles there for each of those. Each pair of angles is supplementary. That is true as well, because if they're 90 and 90 plus 90 is 180, that's supplementary. The transversal is perpendicular to the other line. Absolutely. Every pair of angles is complementary. No, that's not true. That means the two angles would add to get 90, and that's not the case. Okay, let's take a look at 41. In order to prove line N is parallel to line O. So I'm looking at N is parallel to O. Which angles would need to be congruent? Justify your answer. Well, that means I would have to have a transversal. If I use M as my transversal, then 5 would correspond with angle 1, and corresponding angles are congruent. So angle 5 and angle 1. Now if I were to use this line as my transversal, well then let's see, I would need to, I don't have any angles that I could use. Not in these angle groupings, just because, oh no, is that a 4 right there? I could use angle 4 is congruent to angle 2. Oops, I almost missed that. All right, so angle 4 is congruent to angle 2, and how do I know that? Because they're alternate exterior angles. Here's the interior region. These are on the opposite sides, so by alternate exterior angles, I could say that those two lines are parallel. All right, in 42, which cannot be used to prove lines M and N are parallel? Okay, so let's see. I want to prove M is parallel, or we're going to use which cannot be used. Okay, that means my transversal is this guy. So let's see, angle 2 congruent to angle 4. No, that's corresponding angles, so that works. 4 is supplementary to angle 7. Yes, that's true. And the reason is, well, I could say that 4 is vertical to 6. So 6 is congruent to angle 4. And 6 and 7 would be supplementary. Same side, interior angles are supplementary. Angle 4 is supplementary to angle 5. Okay, so what's wrong with that? Is that 4 and 5 are in the same angle grouping. That does not show the two lines are parallel. So this is the one that's not true. In 43, lines R and S are cut by a transversal. So I'm going to draw a picture. Here's line R and here's line S. And I don't know if they're parallel or not. I kind of drew them looking parallel, but it doesn't matter. So that angle 1 and angle 2 are same side interior angles. So here's angle 1 and here's angle 2. They're on the same side of the transversal in the interior region. If the measure of angle 1 is 8x plus 40, and the measure of angle 2 is 12x plus 20, same side means supplementary, so I know they're going to add to 180. Let's go ahead and work a little bit of this arithmetic. That's 20x plus 60 is 180. Subtract 60, 20x is equal to 120, and x is equal to 6. All right, and the next problem says use the figure for 44 to 45. Given R is parallel to S is parallel to P, which angle is not congruent to angle 4? Okay, I'm looking at this angle right here. Okay, angle 2 would be a corresponding, so that is angle I'm sorry, I think this is an angle 6. That would be an alternate interior, so I'm going to knock out those two because those are congruent. Angle 5 is also alternate interior, so it must be angle 3. And that is true because there's not a relationship with 3 and 4. In 45, given R is parallel to S is parallel to P, what is the measure of angle 1? Okay, so let me clean this up. And what do we know? What is the measure of angle 1? Well, let's do some math. Let's see. 40 is up here, so I know angle 3 is also going to be 40 because those are corresponding. Okay, I don't know if I need this or not, but I'm going to put a 40 right there because those are vertical. 30 is over here. 30 corresponds to angle 5. And let's see, what else do we know? Well, I know that these three angles are going to have to be 180 because they're on this straight line. So if I have one angle that's 40 and one that's 30, that adds to 70. So 180 minus 70 is 110, and that would be C. In 46, given angle 8 is congruent to angle 2. Okay, so just looking at those, here's my transversal. They're on the alternate side of that transversal, and they're in the exterior region. So I'm going to say that these are alternate and exterior angles. And we want to prove that these lines are parallel by the alternate exterior angle converse. Proves those lines are parallel. If angle 2 is equal to 4x and angle 6 is equal to 3x plus 25, what value of x makes the lines parallel? Well, these are alternate exterior angles, which are congruent, so I'm going to set them equal to each other and just solve. So if I subtract 3x from both sides, that's going to just give me x is 25. And the last problem, 48. Given that line PQ is parallel to RS, so I'm going to just draw some little chevrons on here so I know that these are parallel. And ON is perpendicular to ML. All right, so this is a 90 degree. This is also a 90 degree. They're all 90 degrees. And the measure of angle 1 is 32. Okay, determine the values of all the other labeled angles. Okay, so if I know the measure of angle 1 is 32, I know the measure of angle 4 is also 32 because those are vertical. All right, so then 180 minus 32, let's do a little arithmetic, 8. How about 148 for the measure of angle 3 and 2 because those would be a linear pair. All right, so 32 and angle 3, which is 148, would add to 180. And 148, angle 3 is vertical from angle 2, so angle 2 is also 148. Let's see what else. Okay, I could find the measure of angle, whatever this number is. I believe that's a 5. And I can do that because I know this is 90 and this is 32. And the three angles of my triangle have to add to 180. So 32 and 90 are 122. If I subtract 122 from 180, that's a 5 and that's an 8. So this angle here, I'm going to call this an angle, whatever 5 is 58. So angle 5 is 58. 5 is vertical from angle 7, so 7 is also 58. Okay, let's find the supplement of that angle, and actually we've already done that. We have a linear pair with 7. If 7 is 58, then angle 8 is going to be 122 because these two are a linear pair. And so angle 8 is 122. It's vertical from angle 6, so that's 122. And let's see, what else do we have? What I can identify is that angle 9 is corresponding with angle 7. They're in the same angle position. And so I know that angle 9 is going to be 58. And I know that 9 and 10 must be complementary because the other two angles in that angle grouping are both 90-degree right angles. So I know that 9 and 10 have to add to get 90. So if I know the measure of angle 9 is 58, then 90 minus 58, and let's do a little bit of arithmetic. Let's see, how about 32? All right, and that